Hi, good afternoon to all. Okay, let me admit everyone here first. So I think I have the full class today. Okay, a very good afternoon and welcome back to Virtual Taylor's University. So today we are going to talk about the basically the briefing about what safety in process plant design is, and also we are going to talk about the assessment. What is our assessment plan for this module? Then we will continue with our first lecture. So for this semester, I may do hybrid mode, meanings I may do mixed mode, meaning some of the chapters will be pre-recorded. Some of the chapters I will do virtual synchronized sessions like right now what we have, because I realized that I lost some of my students if I do all online videos. So I'll prefer to have mixed mode with you all. And also all tutorial classes will be synchronized, meaning you have to come and we are going to have discussions during our tutorial class. Okay, just give me a Okay, let's start. Okay, see if there's anyone still in the lobby. Okay, so yeah, if those who are from the TCF, meaning intake 2018 and above, then you will be seeing this code as CHE60504. Those who are taking this as an elective from the semester 8, you will see this code as CHE61403. Okay. So content-wise, they are similar, but assessment-wise, students who are taking this as 4 credit hours will have slightly more assessment to do. Yeah. Okay. So as I mentioned just now, this is basically what is this about. So this module talks about hazards, human error, hazard, and why we need to study safety when it comes to design. We will focus more on process safety instead of workplace safety, which we're going to go through it like asking like what is to know the differences between process safety and also workplace safety. They are very different. Okay, and this semesters we won't have any face-to-face in-campus classes for this module. So lectures and tutorials are all online. We're going to have mixture of Zoom classes and also the pre-recorded videos. Okay. So here's the learning outcome. First, when we talk about safety, we need to know what are the laws that govern the standards, the codes, and also we need to know about what we call as process safety management. So for those who are graduating soon or is going to look for a job or internship, in the future, they might ask you, what do you understand about process safety management? Because this is like a basic principle about process safety. Okay, and also of course LO2 talks about the hazards of chemical and chemical processes. So we will focus more on chemical plants. Yeah, on later on for those who are from the CE programs, you will notice that you will apply a lot of knowledge in these modules in your group project too when it comes to safety analysis and also your route selections for your chemical processes. And the third LO is we're going to study about the risk in all process plant using qualitative and also quantitative approach. Qualitative means things that we cannot measure, but we can see, we can feel using our own judgment to say, oh, this is good, this is bad, or etc. Quantitative is where we put everything into data to study about them. And of course, lastly, we're going to talk about the lifelong learning in terms of safety and health, etc. Okay, this is where you're going to attend several training to fulfill this LO. So for this semester, okay, the continuous assessment is 40% and final exam is 60%. And therefore, there is no hurdle, meaning if you pass the module with 50 marks and above, then you pass this module. There is no hurdle for this semester. However, if any students fail this semester or decided to drop it, because now is the add drop period, you can still do your add drop. So if you decided to drop it, bear in mind next semester onwards, this module will be 60% continuous, and 70% continuous, and 30% final exam with hurdle. Meaning, even though it's 30 marks, it's 30% for final exam, but if you fail the final exam, you fail the module. So do bear in mind that there will be changes for this module because we are currently looking at putting in hurdle and increasing the continuous assessment component for this module because it's safety. So we want you all to have more practicals in terms of case study analysis, etc. instead of testing you on book base. However, because of EAC requirement, if we reduce the final exam component, meaning you're going to have hurdle. So if you fail final exam, you fail the module, so you have to resit the module. Okay, any questions so far? If no, then I go to what are the assessment and what's the expectations for your assessment in here. Oh, I have a mistake here. Sorry, this one. This is not here, but this will be in week 14. Oh, sorry, it's correct. Oops, how do I? Can I just do an eraser? Yes, this is correct. Okay, so there will be one test, okay, in week 6 or week 7. It depends on, most of the time I will do it in week 6. Yeah, we do it earlier because week 7 is where most of the lecturers will love to have their tests in week 7. So for me, I would rather do it slightly earlier. So this test will be an online test, open book, open source, but within 1 hour, you have to submit the test, okay? And so that is the test, 15% on week 6. And assignment 1 is 20%. And there are 2 parts of this assignment. Okay, they are group and also they are individual assessment. Okay, so what happens is that there is a report for this assessment, means this is a case study. You will be given a title and then you have to form a group of maximum 5, normally 3 to 4 or 5, not more than that, okay? Because of EAC requirements, maximum 5 in a group. So don't come to me and say, Miss, I need 6. In that case, if you come to me that you need 6, I'll split the group into 3. That's simple. So I let you all form your own groups, okay? So, and some students, they prefer to do it solo. You can also, if you want to, you decided not to have any group, you prefer to complete your assessment by yourself, you can also, but it will be easier to work in group. Okay, so 10% for the report. There will be report 10%. And that's a presentation. 10% also for this. That's why you see a 20% here. Okay, so report submissions is on week 10 and presentations is week 11 to week 13. Yeah, so depends on the group amounts, and so every week there will be groups presenting and you will be the judge for your friends during their presentation. So please be here because these are past cases, incidents that happen in chemical processes. So you have to know, to understand and learn from that. Okay, so that's assignment 1. Assignment 2 is pretty simple because this module is a semester 6 module, means all of you are at least in year 3. Either you have done your internship or you are going to have your internship next year, doesn't matter. But the most important thing in here is that you have to know how to choose your own training. So assignment 2 is where you will have to attend minimum of 12 hours training. and write a report for each trainings that you attend. So some trainings are 2 hours, some trainings are 3 hours, some trainings are 1 hour. So we are going to go detail about what are they later. Okay, when I issue the assignment to out in the portals, it will explain to you. Some of you says, oh, I didn't want to attend any physical training. Can I attend webinar? The answer is yes, as long as it's a form of training to enhance your knowledge in terms of safety. Yes, it will be counted. Or some students may even say that, oh, I prefer reading. So reading also can. So every 1 journal paper is equivalent to 1 hour. So either you read 12 journal paper, or you attend 12 1 hours training, or you attend 2 trainings that is one of 4 hours, another one of 8 hours also can. So it really, this is up to you how you want to design your own training. Okay, so this is the training assessment 5%. The marks is only given very simple to you on how fast, how many trainings do you attend, because some students at the end of the semester, they say, oh, I don't have 12, I only have 8. Then a certain percentage will be deducted. Okay. So then, of course, your final exam. Any questions so far, class? If no, this is the learning references. So the means of communications will be using Times, and also these Zoom sessions where you can ask questions, etc. In the past, I used WhatsApp group to also have a faster communication. However, I receive feedbacks from students saying that they are not comfortable to be placed in groups. Because when we say WhatsApp means your personal phone number, and some of you may feel that, hey, that's my personal phone, I don't want other people to know my phone number. And so that is why this semester I leave it to the group that you're wanting the WhatsApp group for an easier communications, or you're okay with Times communication. So meaning any announcement, any communications, we can go through Times, and if you want to reach to me, then you just drop a message in Times that I will reply from there. Which one do you all prefer? And anyone? Okay, so in that case, I see some says WhatsApp, some say good and okay with Times and all that. So in that case, what I would do is that I'm going to open a WhatsApp group. So if you feel like you want to join, I'm going to post it in Times. You feel like you want to join, you can join that one. So any communications in Times, I will again post it in Times. In WhatsApp, I'll again post it in Times. So for those who doesn't want to join the WhatsApp group, yes. And also, please don't message me in midnight. Yeah, you can leave the message here and don't expect me to answer anything after 6. Yeah, because that's family time. And even for you all to have a healthy lifetime, after 6, don't look at this. Okay. Any questions so far? If no, then okay, discard. We're going to talk about our lectures for today. Let's see which one is this one. Any questions about the SOW or the MSOI about this module, what we are going to do this semester onwards for this whole 14 weeks? Okay, let me open up. Okay, I guess you can see now. So introductions. So, okay, I will off my video because the line is a bit, yeah, someone asked, so this module has no physical class. Okay, for this semester, for CE's offer module, meaning any modules that offered by CE lecturers, lecture and tutorials are all online. Okay, only practical lab, because EAC wants us to have practicals, to have hands-on. So labs have to be physical. The rest are all online. Okay, partly also because we have to control how many students in the campus to avoid the spreading of the virus, and also to reduce the chances of too crowded in the campus. So there's only a few programs that are coming back to campus. Engineerings are one of it. Engineerings where only practicals are one of it, and also any computer labs, because we also receive feedbacks from students saying that their laptop or their computers are not powerful enough to run some simulations programs like SolidWorks, Unisims, etc. So if you have computer lab, then you will come back for physical classes. If no, then lectures and tutorials are all online. Okay, so I hope that answered that questions. Any other questions? If no, then we'll talk about today's classes. So first question is, why safety? Why do we want to study safety? Anyone? Shall I call name? Come, give me some answer. Why do we want to study safety? Come on, class. Avoid accidents, that's a good one. Anyone else? Hello. So quiet. Okay, well, I'm going to call name. That's what I like to do. Task can't be done properly. Okay, that's a good one. And okay, let's see who is that. Muhammad Ahmad, would you like to tell me why do you want to learn safety? Oh, protect ourselves, avoid death. Good. Come on. More. Yes, protect environments. That's a very good one. Anyone else? Avoid property damage. Yes. Those are the things that we want to look at. Okay, as chemical engineers, okay, let me be very, very blunt in this case, because since you are in this, you're already in your year 3, or some of you in year 4. As chemical engineers, our responsibility is huge. It's not just about property damage, but it's about safety of the society, of the community. So I give you an example. Remember, if any of you have taken chemistry, some of you may not have taken chemistry, but I assume all of you have taken chemistry in your Form 4, Form 5 in your high school. There was one experiment where in the test tube that is filled up with hydrogen gas, and you put an incense in it, and immediately it go pop. That is only like 10 mL of hydrogen gases. Can you imagine our job as a chemical engineers? We no longer talk about 10 mL. Okay, the differences between a chemist and a chemical engineers is that a pharmacist may go to a chemist to say, I want 10 mL of paracetamol, Panadol, to cure a headache. The chemist would then go to the lab and mix chemical A, B, C, D, E, F, G, throw it all together and come up with the reactions and come up with the formula and create Panadol. That's the job of a chemist. But then when he or she go back to the pharmacist and say, look, here's your 10 mL of paracetamol from A to Z chemicals that mix up. And here's the formula. Here's the reaction. And the pharmacist will just look at the chemist and say, look, that is only for 4 hours for one patient. What I have here is I have 10 patients that they need 3 doses a day. I need more than that. And there are a lot of people out there that need paracetamol, so get me more. But chemist's job is only the small scale. So what chemical engineers do is that's where we kick in. We come in and say, okay, we take the formulas, we take the reactions from the chemist, and we expand it to a chemical plant to produce like 10,000 tons or metric tons of paracetamol a month. to provide to worldwide, to provide to Malaysia, or to provide to whoever need it. So our job is no longer the small scales. Out there, chemical engineers' job is to take care, is to design the process plant in a big scale. So in other words, going back to the hydrogen test tube, we no longer look at the test tube size because that is the job of a chemist. But we are looking at the chemical engineer size of hydrogen storage tanks, maybe the size of block A plus block B in Taylor's University. So if it go pop, it's no longer a pop. It will be a big bada boom and becomes a cradle. So safety become number one issues for all chemical engineers, because imagine anything happens to, if let's say imagine that Taylor's campus is the chemical plant that store hydrogen tank, that has the hydrogen tank storage, and it goes boom. It's not just Taylor's campus is going off, the whole Sunway PJS7 is going to be a cradle. So safety is number one priority for chemical engineers. Always remember that we do not mess with safety. It's not just harming others, it's not just protect environment, it's not just damage, but it's everything of all this. Okay, so that is why these modules normally chemical engineers will learn in year 3 or even year 4, because that is where your brains, your maturities are there. After 2 years of studying, 2.5 years of studying chemical engineers, like all the reactions, you have learned about the thermodynamics, you have learned about heat transfer, heat release, etc. So here we understand all of them, and here we look at how we control them, how we eliminate those risks in that. So that is why we are here today. It's a core module for all chemical engineers students. It's elective for mechanical and E&E, and also it's a core for civil engineering. Okay, so here's a little bit about history. Just now we talked about creating Panadol from 10 ml to 10,000 metric tons a month. So in the 1800s, the chemist only knows about 100 types of chemical elements. So if you see the progress of the chemicals discoveries and the chemical productions over the year, we realize that nowadays, for us today, for you who are graduating soon, the chemical process that you have or that you are going to be involved in are huge. And a lot of them involve corrosive, toxic chemicals, flammable chemicals, and also the processes. We are not talking about 100 degrees Celsius, we are talking about 300-400 degrees Celsius at 20 bars. It's at high pressure, high temperature. So that's where safety kick in, okay? So safety is about systems, about attitudes, it's about the fundamental knowledge and also the experience, okay? One thing in safety that we can't escape is the more experience you have as engineers, the more you realize, that the easier you realize those knowledge, those common sense comes about, okay? And of course, talk about times and talk about you yourself, okay? So in safety, we also talk about another words, which what we call loss preventions. What is loss preventions? We always heard these terms, okay? Loss preventions is about converting the losses in terms of money, in terms of value, to put that in the values with a dollar sign in front. So you notice that you talk about financial loss caused by an accident. So the loss preventions, the loss includes cost of replacing the damaged plants, and also if there's any insurance claims, if there's any lawsuit, okay, then the company will have to pay because as I given you the example just now, when there is an explosion, it's not just the plant itself, but the buildings, the houses, the properties around them, or even people's life. Okay, so the company will have to pay all of it. The loss of earning from lost productions where you stop production because the plant is damaged, and also the loss of sales opportunity. So loss prevention is where we want to study how to prevent all these losses. Okay. So manufacturing process designer means us chemical engineers, is you are going to, if you're taking this module together with process plant design and economics, you will notice that these three modules go hands in hands. And especially if you're taking together with process control and instrumentations, you will notice we are basically brothers and sisters talking to each other, but from different facets, from different aspects of the chemical process plant. So as a process designer, okay, where you design a plant, somehow we are going to involve in some hazard situations. Means when you design a reactor, you can't give, how to say, we can't avoid saying that, oh, the reactions need to take place at 400 degrees Celsius, but I don't want to design it at 400 degrees Celsius. But that doesn't work, because if that's the case, that's what they are going to have. So if the reactions need to take place at 400 degrees Celsius, it has to take place at 400 degrees Celsius. So as an engineer or as a designer, we have to be aware of all these hazards. We have to know that how do we reduce them. So the keyword here is to reduce the risk. Okay, that's why we are here. That's why we're going to talk from chapter to chapter, like all the risk study and how do we reduce them. What can we do to reduce those risks? Okay, and the design engineers should always consult those laws, regulations, and standards before you make decision. Okay, so it's a boring chapter because we're going to talk about law, we're going to study about regulations, standards, and blah, blah, blah. But those are there to help us. Okay. So of course, we will have to adhere to our engineering ethics. So where our job, engineers' job is to enhance humans' welfare. And with that, we have to be honest. And with that, we also must continue to increase our competency as an engineer. That is why you notice that our LO4 talks about lifelong learning. That's where I want you to go and find your own training. Because if you stop your learning after you graduate, then you are always only a graduate engineer. I would love to see my student progress from graduate engineers to a professional engineers, where every year you will know, like, okay, this year I want to learn about, I'm in job A here, I want to learn about the processes in job A. And if after 1 or 2 years you realize that, okay, now I want to learn about how to improve the processes, I want to know more and more. So you have to continually improve your own knowledge in terms of technical, in terms of practicals, like on-the-job trainings, etc. So training is a must. It's a compulsory element in the company to give you training hours every year. Okay, so that is where engineers do not stop learning. Okay, so these are some ethics that we talk about. You can only do perform service in your own area. So if your expertise is in wastewater, then you work only in wastewater. Excuse me. You don't go into biochemical processes to say you want to work in that. So focus on your area of expertise. Of course, you can change area later. Hold on, my throat is very itchy. So first, you have to work, only perform service in your area of competence. And also, you have to be professional. When we say professional, means you uphold the honor, the integrity, and the dignity while you work. Okay, so after this course, most of you are already one step nearer to become a full engineer, a graduate engineer. Okay, so again, as engineers, we always like to look at numbers. We can't live without numbers. Yeah, so accidents or safety, we only measures by a few things here. Is what we call accidents and loss statistics. So we have OSHA incidence rate to talk about lost workday, or even incidence rate, the number of cases. And British like to calculate their loss statistics by fatal accidents rate. They call it FAR. Or another common use, what we call fatality rate, or death per persons per year in different manufacturing. So you will realize all these are talking about accidents, death, etc. So all these methods report a number of accidents and fatalities for a fixed number of workers during a specific period. So you don't have to worry about the formulas here, or any formulas in this safety module, be it an open book exam or if it's a closed book exam, all formulas will be given. Because we are in semester 6 or semester 7 now, and I would expect you all to focus more on applications than memorizing formulas. Because leave the memorizing works to a pen drive. Use your brain as an engineer. Okay, that's where the brain power come in. So OSHA incidence rate counts by 100 workers year. Okay, so assuming each one's work 2,000 hours. So how does this 2,000 hours come about? Okay, this one is where 1 year we have 52 weeks. Hold on, let me. Okay, just write in. So 1 year we have 52 weeks. And as workers, every workers are entitled for, according to labor law, up to 2 weeks of annual leave. Okay, so if you go to a company and they tell you, oh, you do not have annual leave, don't work there, because that's clearly against labor law. As a humans, we are entitled to have our annual leave, have our break over the years. If you work for 52 weeks a year, you're entitled for at least 2 weeks of annual leave. Okay, so that is where it is calculated. So 52 minus 2 here is calculated at 50 weeks, working weeks per year. That is why you notice that here we talk about 50 work weeks per year. Okay, so this is how the first calculations come about. And how do we calculate 40 hours per week? According to OSHA, healthy work hours for a normal human is 8 hours a day. Okay, 8 hours a day, 5 days per week. So nowadays, a lot of companies, they start to practice flexi hours. Okay, or if you notice that you're given, okay, you're supposed to work from 8 to 5. Okay, but you calculate 8 to 5 is like 9 hours. 8, 9, 10, 11, 12, 1, 2, 3, 4, 5 is 9 hours. So what happens to the 8 hours work week? Okay, work day. If companies calculated as 9 hours, means they give you 45 minutes for your lunch break and 15 minutes for either the morning or afternoon break. Some companies will say your working hours is 8 to 6. 8 to 6 is where they incorporated 2 hours of break in between. So 30 minutes for morning break, 1 hour for lunch break, and another 30 minutes for afternoon break. So you'll notice that the actual working hours is 8 hours a day. Anything work beyond that is either by your own goodwill or the company will have to pay OT. Okay, so 8 hours a day times 5 days a week is equivalent to 40 hours per week. So nowadays, company will also say, well, we are doing flexi hours here. As long as you come into the company 40 hours a week, you can do like 4 days. Like some people work 10 hours a day. So they come in 7 o'clock in the morning, work until 8 o'clock at night, take a few hours break in between, and work up to 10 hours a day. So the person's only work 4 days and he or she has Friday off, or he or she have Monday off and work Tuesday to Friday. So it's up to you how you want to plan it. So a lot of flexibilities are given to people who are working right now, but the gist is still there. Standard working hours per week is 40 hours per week, and per year is 50 weeks a year, where you entitle for 2 weeks annual leave. So when we do that calculations, okay, let me have this. You have 40 hours work week and 50 weeks per year. So if we are to write 40 times 50 is where you get 2,000 hours per year per worker. Okay, got that? And since OSHA calculate this as 100 worker years, so this 2,000 times another 100, you get 200,000, which is this value here. Okay, so this is how you calculate. So the OSHA incident rates can count by injuries or illnesses or by lost work day. Okay, what are the difference between incidence rate and lost work day? Any idea? Yeah, plus? Let me change the pen color so that it's easier to see. So we have now the OSHA incidence rate. Incidence rate. So there are 2 types. One is lost work day. Okay. One is number of injuries or illnesses. Okay, lost work day is, okay, let me go back to that. Lost work day focus on numbers of days that the worker cannot do work, that worker cannot work. Meaning if, let's say, the person's injuries is now in hospital or having MC, so if the person is hospitalized for 2 days and MC for 60 days, the numbers of days that the workers lost, this one is then 60 plus 2 in the hospital, so total of 62 days lost. Okay, so if you are to calculate the incident rates, it will be, let's go back here. That's where you will see 62 here with 200,000 and total hour works by the all employees. Meaning if let's say 2,000 hours per year for that person's, that one person's, and they have 1,000 worker, for example. So this will be the total hours. Okay, so then you calculate what is the incidence rate in terms of lost work day. Okay, any questions here? So we are going to talk about what about the injuries and illnesses. So one incident is considered one injury. So if a worker's fall, for example, someone fall down, one worker fell from staircase. Okay, and so like what happens was he broke his leg for so he was hospitalized for 2 days plus 60 days because he cannot work, he cannot walk, etc. of MC. So total lost work days will be 62 days lost. Okay, in terms of lost work day. But in terms of number of injuries, is considered one case. This is one injury. Okay, so you will notice that the numbers are very different, but both will tell us how severe is the case. Without both, you will not only see, oh, there's 100 cases per year, but without looking at how many days that being lost, you will not understand how severe is that incident. Because it really depends on the company, what sort of injuries that they report. Paper cut is considered an injury. It's a workplace safety injury. So as simple as paper cut, do we report that? Does the company wants to do that? It's really up to the company because paper cut is small things. But if the person is using the cutting machine and chop off his finger, then that's a serious case. So it really depends on what the companies classify as reported case, and also how severe the cases are, because paper cut, you don't need lost work day. It will be 0 lost work day, but it will still be considered as one injury. Any questions here regarding the OSHA incidence rate? Oh, how do I get back? Oh no. Okay, it's back here. Any questions here regarding this one? If no, then we go to the other calculations, the fatality rate. Okay, fatality rate are mostly used by British chemical industry, and it counts in the calculations instead of like OSHA's incidents count by 100 people, yeah, 100 workers. FAR rates count by 1,000 employees, and the calculations are slightly different because they look at assuming a person's work for 50 years, okay, and therefore 50 years and every year is still 2,000 hours per year. From the previous calculations, the 40 hours per week, 50 weeks per year. Okay, so and work for 50 years with 10,000 employees. So you will notice that this one times, okay, oops, this one times 50 years, okay, times 1,000 employees, you will get this number, 10 to the power of 8. Okay, you can do your own calculation. So that's where this number of fatality times this value and divided by total hours worked by all employees in that company is the FAR value. Okay, this is how they calculate. Any questions so far? It's quite straightforward. If no, then we go to fatality rate. Well, fatality rate is another method to estimate, but it talks about per person per year. Okay, so number of fatality per year over total numbers in the applicable populations, meaning it's not in one industry, but if let's say, for example, this talk about the food making, food packaging industry. So they would divide by how many people working in all the food packaging industry. So if we have 10 food packaging manufacturing in Malaysia, they will add up everyone in there. So this data show us in the populations, they will have to tell, okay, this is in Klang Valley. This fatality rate is in Johor Bahru. This fatality rate talks about the entire Malaysia. So they will tell you the locations because they will have to incorporate everyone in that. Okay, so any questions? This is a straightforward calculation. There's no assuming like how many hours and etc. If no, then we can take a look at this data. This data, I just got it yesterday from DOSH Malaysia. DOSH is our Department of Occupational Safety and Health Malaysia. It's the government's department. So they will look at all the incidents, okay, accidents, and also they'll do the statistics according to every sector. They also do another data according to every state. Yeah. So this data is from January to November last year. And you can see hotel and restaurants, the NPD stand for non-permanent disability, means it's just the incidents or the injuries can be recovered, like broken arm, then the arm will be recovered. Okay, permanent disability means they lost part of their body that consider permanent. Okay, so they do all this, and you'll notice that the highest number is still, but this is only raw number. This has not put inside FAR, this has not put inside OSHA incident rates, and this has not put inside the fatality rate. It's just a raw number to tell us how many people got injuries in that sector. Okay, so if you want to convert them into FAR, if you want to convert them into the fatality rate, then you will have to get the populations of that area in that manufacturing, in that sector. Any questions so far? So these are the data that you can easily get from the internet, from DOSH Malaysia, if you're looking at DOSH Malaysia itself, but you can get it if, let's say, you want to do plant design and you want to put your plant in Indonesia, then you will have to go to the Indonesia's government site to look at what is the incidence rate there. Is it high? Is it low? Is that safe for you to have this plant in there, etc. This helps us to make decisions on where do we want to set up our manufacturing as well. Okay, any questions so far with all this data? If no, then the next part we're going to talk about like the accidents pyramid. Okay, every 300,000 on unsafe act. That how a very good example here is reckless driving. Some people, they run through red lights. Some people, they just don't care. When they cross road, they don't see, or they just cut line without looking at. All these are what we call unsafe act. Okay, every 300,000 of unsafe acts, it always creates about 600 of near-miss accidents. Okay. And every 600 of near-miss accidents, there's always a statistic shows that there's about 30 minor accidents happen. When we say minor, means like if we talk about the accidents on the road, it may be just a simple bump, no injuries, or may just a small slight injuries. Those are what we call minor. Okay, and for every 30 minor accidents or every 3 minor accidents, we often see that unfortunately one is often a serious accident. Okay, so every 10 serious accidents, there's always one fatality. And so what we want to do here is when it is already here, it is, I would say, too late. Okay, we can still work on minor accidents, but accidents already happen. Okay, so as an engineer, we often want to focus on these two areas, especially near miss and also any form of unsafe act that run by your employees, your operators, or even yourself. Okay, so especially when later on you work as a process engineers, you work as a maintenance engineer or a service engineers, you will notice that people around you, sometimes they do small little things that you go like, hey, why like that? Sometimes you realize that they are doing some welding without proper PPE. Okay, or they are pouring chemicals without wearing masks, without wearing goggles, without even wearing gloves. Those are what we call unsafe acts. Those are the ones that we want to start taking action. So if we can reduce this one, any of the unsafe acts, we will reduce the chances of near miss. And of course, all this here, we get to reduce them. Okay, because one fatality accidents, sometimes it's not just one life. We are talking about cases here. Sometimes one fatality cases or accidents can that may involve maybe a community. Okay, looking at the reasons, I won't say it's still quite reason. Last year, if some of you have watched the internet and all that, that's inappropriate storage at the ports at Beirut. Okay, what they store was simple chemicals. It's just fertilizer. But because the amount was so huge and the temperatures was bad and there was a fire, and then it becomes a deadly accident. Okay, so all these are small little things. It starts from unsafe act. It starts from people think that, oh, it's okay, I can solve that. If nothing happens, nothing happens. But when things happen is where it becomes serious. Okay, so who knows that harmless, it looks so harmless, of just fertilizer we use it every day. If you have plants at home, if your parents doing plantings, they bought fertilizer. We have fertilizers at home, we have fertilizer in the university to work on, because for my research area, I work with control release fertilizer, so we use fertilizer. It's such a harmless to us, it's such a harmless chemical. But when we store it at a certain amount, it becomes fatality, because a fire happens nearby, and that's where, when the chemicals has enough energy, it break into two types of gases. What causes the explosions was not the fire, but it's because of all these elements, small little bits of fertilizers got enough of energy that it vibrates so fast that it can break off. That part of that actions of breaking, the exothermic reaction of splitting that two chemicals, two gases, from a solid form into a gas form, is the one that causes the crater at the port there a year ago. So if some of you have no idea what I'm talking about, you can just Google Beirut incident or accidents, and you can see how bad before and after. The port was literally a cradle. Okay, so unsafe acts, it started from all this small little unsafe act. Oh, I stole this, doesn't matter. Oh, I do this, doesn't matter. Oh, I'm just going into the lab to grab something fast, I don't need PPE, is okay. Those are not okay. Okay, so all these are the unsafe act that we want to work on. If you notice, some of you have seen me in the lab. I often go in and call students and say, hey, you shouldn't do this. Where is your mask? Where is your glove? And I give students that what they call the ticket, yeah, to bar students from entering the lab for a day or two, especially when you are doing your FYP project next semester, for those who are in semester 6. Please make sure you follow the rules and regulations in the lab. Okay, because I will not tolerate any unsafe act in the lab. Okay, all the near-miss accidents, you must report them. You can't just say, it's near-miss, now I just don't care, because near-miss means the accidents already happened. It's just that the person is so lucky that get away without any injuries. But it doesn't mean that it is safe. It's already telling us it's not safe, let's take action. Okay, so if any near-miss accidents, it must be reported. Remember that. And it must be taken actions on, what we call a CQI actions, to counter this, to prevent this from happening. Okay, any questions so far? This is straightforward, this accidents pyramid. Okay, so unfortunately, the fact is that there's no way we can eliminate risk entirely. It's like a risk of falling down. Some people, they're just clumsy, they can just walk, and boom, they just fell off. It's just human. We can't eliminate risk entirely. Even some people sit in the chair. When we were in the classroom, some people can't just sit on the chair with 4 legs. Even if you are at home right now, if you don't have those, if you have those 4-legged chair, some of you may be sitting on it with 2 legs. Okay, and the next thing we know is poof, that person fell off. Okay, there are certain risks that we have to accept. There are certain risks that we cannot accept. So as an engineers, we are given the power to draw the line. Where is the acceptable risk? Okay, anything below the acceptable risk, we won't look at it. Anything that above the acceptable risk, we will take action. No. However, it's just like people who love to sit with 2 legs chair, and instead of 4 legs, there's only so much we can do. We can just tell them, hey, sit properly. Then the next thing you see, that person's go back to 2 legs sitting. So there are certain things that we can do. There are certain things that is out of our control. There are certain things that we'll just give them warning. Especially if you go back to high school classes, teachers will just cane and say, come on, sit down properly and all that. But the risk is still there. Okay. So we, the someone here, is the engineers. Very often, the engineers are the one to decide whether the risks are acceptable or not. So that is important for us to do risk assessment before we say, oh, this is acceptable risk or this is not acceptable risk. And always remember one thing, no engineer should ever design a process that knowing at the end of the day, there will be human loss or injuries, regardless of any statistics. Meaning you cannot design something that you know it will definitely kill someone. You cannot design something that you know that one day is going to explode, and then you just say, never mind, that one day is not today. We cannot do that. If you know something is going to happen, we have to take action. Okay? Any questions about acceptable risk? It's as simple as that. Okay, and all accidents happens with 3-step sequence. Okay, when we say 3-step sequence is where initiations is where we call that where it starts. Okay, and then the accident sometimes it propagate. It will not just end like that. It takes days to end, or maybe it just takes seconds to end, but it get prolonged. So we want to see what prolonged it. Okay, the propagations. And of course, this is where terminations rates, where it stops. What stopped it? So when we analyze an incident or an accident, okay, there's always 3 steps. And what we can do is all 3 steps, we can take actions. Okay, some is what we call preventive action, some is what we call corrective actions, meaning if there is a fire, termination is to stop the fire. How do we stop it? Maybe we have sprinkle, maybe we have the fire extinguishers, we have this, we have that to stop it. So that is actions taken to correct the accidents. But what started it? Maybe a simple one, someone smoking at the petrol kiosk started the fire. Okay, so how do we stop or prevent this from happening? You see, wherever petrol kiosk you go in, they always say do not smoke. That's how we do. And the authorities would then have to go in and catch people you smoke at the petrol kiosk. So please, and remove those people or give them summons or give them a ticket and to tell them to stop doing that, because if there is any fumes around that area, they may just start a fire. Okay. And what could prolong, if there's a fire started, what prolongs the fires is how much petrol or how much gasoline they store in the fires, in the petrol kiosk, if a fire's ever happened. Okay. So any questions so far? We're going to look at this example. A long time ago, this was way before I was born. Okay, a worker come across a high walkway in the process plant. That was like 60 years ago, process plant, yeah, where it stumbled and fall towards the edge. So a lot of process plants, even until today, you realize that if you ever have a chance to go a plant visit, you'll notice that the walkway are normally very narrow. Okay, so what happened is this person stumbled and it was like, oh my God, I'm falling. Okay, so to prevent the fall, so he grabs something nearby. And unfortunately, he grabbed a waft, okay, just grabbing the waft, and then to prevent to stable himself. But instead of the waft stable him, the whole thing get pulled off by him, and that the flammable liquid start to spill out from the storage tank or the process tank that he pulled from. So a cloud of flammable vapor rapidly formed, and there is a nearby truck, the engine is on. So when the vapor go there, poof, that's the fire begin. And the explosions and fire quickly spread to the nearby equipment. And this fire lasts for 6 days until everything was burned off. All the flammable materials in the plants are consumed. And with that, the plant is gone. Okay. So let's look at these 3 steps. Initiations. What started it? The worker tree. And propagations. What prolonged it is where the tearing of the waft. That's the first one. Okay, because if the worker just tripped and when he pulled on the waft, nothing happens to the waft, this whole accident didn't happen. Okay, so he fall, he pulled off the waft and supposedly to help to stable himself, but instead he pulled off the whole waft from the process and chemicals start to flow. And also there's a second propagation is that there is a nearby truck. If there's no truck, the fire wouldn't happen too. But if there's no truck and someone's smoking there, the fire will still happen. So it really depends on what propagate the fire. And the termination step is where it consumes all flammable material because the fire was so huge. And I believe at that time in 1969, there wasn't enough equipment to pull off such fire. Okay, so as an engineer, how do we do when we say case study, when we look at cases like this is where we want to see, okay, we are in a plant now that has a very similar design. How do we prevent this? First, we look at initiation. Okay, worker trips. What causes the worker to trip? Is that there's a bump at the walkway? Is that the safety shoes is not at the correct size? These are the things where the engineers will then start to sit down and brainstorm. What happens? What causes it? Okay. So if you can think of like 5 or 6 methods, oh, because walkway not even, for example. So how do you want to resolve it? Yeah. So this is then you think, okay, if that's the case, how do you want to ensure the walkway is even? You have to make sure as an engineer, maybe periodically check the walkway to ensure there's no hole, there is no something sticking out, that the walkways are always being well maintained. So you may put that in your maintenance or the monthly or bi-yearly maintenance plan to make sure there is no rusty, if the walkway is made by metal plate, make sure there's no rusty nuts or plates in there that can make people trip. Okay, so that is where we say as an engineers, when we understand all cases like this, we look at it like this. We will look at what we have today and what we need to do. Okay, so what we're not even, then you want to make sure it is even. So you use brainstorm here, or you can even refer back to those reports that what causes the persons to trip. Maybe the shoe size, like what I say, shoe size incorrect, because he's supposed to wear safety boot, but the size, for example, this person is supposed to wear size 8, but size 8 is out of stock, so the company gave him size 9, so he tripped. That could happen too. Okay, so in that case, you may want to look at, hey, HR department, make sure you get the right PPE. So this is wrong PPE. So you want to make sure the PPE adequacy, yeah, PPE availability. So this is the job of an engineer, to look at safety point of view. Every steps we look at how we can prevent it. We can't, with all this that we done, there will still be people tripping. Okay, there will still be people tripping, and we will still need to but what we can do is we reduce the chances, reduce the risk, the chances of it happening with the best that we can control. Things that we cannot control, if the person is clumsy, is born clumsy, no matter how good, how flat the floor is, it will still fall. Then maybe you may want to send the person to training on how to walk properly, how to be walking mindfully. But again, as I said earlier, we can't eliminate all the risks. But what we can do is we want to reduce it to minimum. Okay? So that's the initiation step. Then propagations, what can we do? Shearing of the valve tell us one thing. This plant has not been well maintained. Okay, let's see. Let me erase some of this, okay, so that I can continue to write. So this one means it is not well maintained. Because if it's a well-maintained valve, it should not just get tear out by human force. It's just not possible. So it tells us that this is a bad welding, this is maybe there's rusty in there. So with that, an urgent maintenance is required. Okay. So you want to maintain it. You want to do periodic checking to look for rust, to look for welding points, and to look for the mechanical integrity of your process is what you can take, because that is under your control as an engineer. You want to, okay, now we can see rust here. So what do you want to do? Maybe you want to down the machines, repair it to reinforce the welding point, or to change the valves, etc. So it's up to you to make the call. What do you want to do when you spotted issues? And so that's one. So the second one, nearby truck. So what can we do as an engineer? You may want to talk to the safety departments to look at, hey, look, now we have this issue here where trucks shouldn't be parked near process area. So can we have all the trucks or all the vehicles to reroute to another area to prevent accidents like this? That is why, if you notice, most of the process plant, inside the plant, there has no truck. That has a designated area for loading and unloading where the trucks can go to, which is far away from the process area. Yeah, so that's another one that we can take actions of. Okay, so do what is under our control. What is beyond our control, we let it go. Okay, so that's where we have covered initiations, we have covered propagations. Now terminations. What can we do? We have like 3 gallons of chemicals that's flammable. Okay, so in their case, they wait until it all burned off. But as engineers, then we want to look at, okay, in the futures, maybe we want to reduce the storage of the chemicals. That is why later in this chapter, we're going to talk about inherent safety. Reductions is one of it, meaning instead of storing 3 gallons, maybe we just store half a gallon. Every time when it's full, we get a truck come in and transport them out to keep, to minimize the effect of if there is fire happens, at least the chemicals that can be burned off is at a very minimum. Okay, and also to put in appropriate fire extinguishers around this area, around all these flammable chemicals, or you want to build a firewall, or you want to build explosions wall. It's up to you to take actions as engineer. Okay, so these are all the things that we can do. So we look at 3-step sequence, the initiations, propagations, terminations, and we take actions in every step to prevent accidents like this to happen in the plants that we work at or the plants that you design. Any questions? Okay, so as engineers, again, you can read there's a wall of text here. It is very unrealistic to expect to eliminate all initiations. There's no way we can put it all, as I said, as I mentioned. So what we can do is we want to reduce the effect of every stage. Yeah. Any questions so far? This is just introductions of this whole module. Then later on, we are going to go into details to talk about the chemicals toxicities next week. And also we are going to talk about hazards of chemicals, like how, what sort of things that you can store, what sort of thing that you shouldn't store. And if you want to store chemicals, certain chemicals, you don't store them together because they just react, etc. So we're going to talk about them in the next few weeks. And in week 5 until week 9, we are going to focus on fire and explosions. What sort of fires are there? What type of different type of explosions available, so-called available, or can be started in a chemical plant? Because different chemicals give us different explosion type. So we have to know what are they, how do we prevent them, or how do we eliminate them, or how do we minimize the effects of that. Okay, so one things that we mentioned just now, like this case study here, this one. the consumptions of all flammable material. So if we want to reduce the fire's day, that it talks about 6 days, one thing is that we can actually reduce the storage of the chemicals in the plant. Okay, so inherent safety is where we restudy or review the processes of every process, every stage of the chemical hazards and risks in the plant, and see what we can do, what we cannot. Okay, so it's best that inherent safety is to be built during design phase, mainly when you do your process plant design in semester 7 and semester 8. You will start looking at, okay, I have these chemicals, this is so toxic. Just a teaspoon of it, when it evaporates, people will die, and you may want to change that chemicals. You may want to look at, okay, in that case, I don't want to use that chemicals. Maybe I use a replacement chemical. Okay, so those are inherent safety. Those are the things that you can do at very early stage when it comes to design a new plant. However, if you start working and you realize that, oh my God, I'm in a plant that is so old that needs to do a revamp, that's where you review them stage by stage to see how you can implement inherent safety in an existing plant. Okay. An inherent safety plan relies on chemistry and physics to prevent accidents rather than a control system. So when we talk about inherent safety, we are not talking about control system. We are not talking about redundancy. We are not talking about interlocks and all that, but we are talking about the natures of the processes itself, the very essence of the process. Like what I mentioned is that, oh, this chemical is toxic, I change the chemical. So you completely eliminate the toxicities completely. Another way to do it is you minimize it. If when you cannot eliminate it, you minimize it. So like what I keep mentioning, if you store a 10,000 metric tons, maybe we don't want to store that much. Maybe we want to break them down into smaller storage tank, and each one we build a different explosions wall, the anti-explosions wall around it. Those are the things that is what we call as inherent safety. Okay, if you can moderate it, that's best. If you can reduce or replace it, that's best. So it does not, when we say inherent safety, remember it is not control system. It is not interlock system. It is not additional redundancy system, but is the nature of the system that you change. Okay, so inherent safer plants are more tolerance of errors and often very cost effective. Okay, so and you can read, there's a lots of text here. So this is what we call the layer of plant safety, and later on you will hear people say the word LOPA. Yeah, layer of protections analysis. Okay, so basically it's this one. So the lowest level is where we say the plant design itself, the inherent safety itself. So when we do all that we can, because sometimes you realize, oh, I still need to use some toxic chemicals. I can't change that because that makes my chemicals. So if there's no choice, then we go layer up. In here, let me change the color. One layer up. Okay, you can't change that anymore. So then we go to process control, which you have learned in your plant process control and instrumentations module. All engineerings will learn process control, be it in chemical, mechanical, E&E, or civil. It's part of your course. Okay, so if your process control cannot take it, the next level we look at is alarms and operators intervention. Okay, so if we still not enough, then the next step we look at is the automatic shutdown system. But until here, if we can do this, this is the best. If we can't, we go one step higher. But a chemical plant will have all of these elements in there. Meaning, after we look at one step, we look at second step. If this fail, we have the third step, where we have alarms that ring and operators will come and intervene. If operators can't do anything, the next thing is the safety shutdown. Okay, so if safety shutdown doesn't work because your reactors, like imagine you have a reactors that runs at 400 degrees Celsius, you shut down the system, but the chemicals is already bubbling in there. You can't stop chemical reactions. So it's already so vigorous, it's going to burst very soon. Then we have the next systems that might save us is our pressure relief systems, which we're going to talk in week 3 or week 4. Okay, the relief system. And if relief system fail, means the next thing is what we call run for your life. So we have to have the emergency response team in process unit, means we need to evacuate people in that area, okay, in the process itself. And if we notice that if there's explosions going to happen and the unit itself is not in evacuations in unit itself is not enough, we want to evacuate the entire city or the town or people around. If like imagine the hydrogen storage tank that we talked about earlier in this class is unstable, you know it's going to burst. Evacuating people around that unit is not enough. You have to evacuate the city. You have to evacuate everyone in Sunway area, in PJS area, if there's a storage tank at Taylor's locations or somewhere nearby Taylor's. We have to evacuate everyone when we say community. Yeah. So this is where a layer of plant safety that need to be in place every time when we have a chemical plant or we have a manufacturing plant. That is why that governments will want to have all manufacturings in one place that is far away from residential area. And also because of that, you notice that the nearest manufacturings around us in Taylor's area is what's that called, the Sungai Way Free Trade Zones, the areas near Western Digital. Governments is moving them out. If you notice that the old manufacturings like Panasonic, now it's already becomes 10 years ago it's still Panasonic, now it's already Icon City, it's already a new building, there's no more manufacturings in there. That is basically how the governments take actions to save life, because chemical processes, anything happens is not stable. Okay, so that is why we want to remove all manufacturing. We want to segregate industrial zone with residential zone. Got it? Any questions so far? I think we're almost done. So 4 simple rules of inherent safety. One is, I would say number 1 is substitute. Yeah, if possible, we want to substitute it. Number 2, moderate it. Okay, simplify it, and also minimize it, or in any sequence that can come in, doesn't matter. So these are the 4 things. If we can change them completely, we are going to change it. If the chemicals is toxin, the chemicals is flammable, if we can change them, we change them to something that is not so volatile, that's not so toxic, that is not so flammable. Okay, if we can't change it, then we see if we can moderate them. Moderate means you use in a lesser amount, or you work with them in a lesser hazardous environment. Means can we, instead of running it at 400 degrees Celsius, we run it at 200 degrees Celsius? How is the reactions? How is the rate of reactions? The conversion rates? How many percent will that drop? If it's only dropped by 2 or 3%, and we can still run it with a good yield, maybe we'll run at 200 degrees Celsius instead of 400 degrees Celsius. Because if 400 degrees Celsius give a conversions of 98% and 200 degrees Celsius give a conversions of 92%, why not? We run at 200. You reduce the condition. Okay, that's where we say moderating. Reduce in a less hazardous form or less hazardous conditions. Okay, so that's where if we cannot substitute it, means we moderate it. And if we, after substitutions and moderations, we see if we can simplify the process. Okay, keep it simple is number one rules in safety design. Lesser instrumentation, lesser valve, lesser joint, the easier, the safer the process is. Okay, so we want to remove all those unnecessary things to make the plants more user-friendly. Okay, so also keep procedures simple. Okay, as engineer, one of our tasks is to write standard operating procedures, the SOP. Nowadays, you hear a lot of SOP in terms of safety for COVID. Same thing, we write a lot of SOC and SOP. SOC is standard operating conditions, which temperature setting, pressures. That's where we can work on moderation here. So this is where you do your SOC setting. And when it comes to SOP, we see if we can simplify them. Okay. Imagine that you want to write an SOP for operators who don't even have a Form 5 educations, because often we have operators who may be at a very low education level, or some company even bring in foreign worker to do the operating job, okay, operational job. So imagine you're working with thousands of workers from other countries that doesn't speak English, doesn't speak Bahasa, doesn't speak Mandarin, or doesn't speak any language that you know, and you want to ask them to follow procedures. Okay, please keep your procedures as simple as possible. Best is to use picture with one-line instructions. Okay, don't give them a thesis or don't give them the assignment that you often submit to us. Okay, don't do that, because nobody's going to understand it, nobody's going to read it when you start to work. That is why if you notice that even for my modules, I'm going to limit pages, because it's easy to write a long assignment. Trust me, if I tell you I want all this information in your assignment and you can only write 2 pages, that's more challenging than a 20-page assignment. Okay, because you want to put in all the information in there with short, concise words. Those are skills. Those need practice. So if you notice later on all my assignments, you have word limit and you also have page limit. So anything beyond those pages, I'm not going to read. I'm not going to mark. So if you write, if the assignment is only limited to 10 pages and you give me a 10-page of introductions, you will lose your marks for your what's that called? Your discussions, your results, and all that. You will only give mark. You will only get the marks until 10 page. So please, when you start to do work, make it a practice. Simplifies your work from this semester onwards. Okay, simplifying things is part of the safety training, especially simplified words. Okay, and also minimize. If with all this, then you see if you can reduce the storage quantity or to reduce the energy storage in your system. Okay, any questions so far? Because I believe this is my last slides. Yeah. So I have my phone number here. Okay, anything you need consultations, you need clarifications, you can WhatsApp me. I'm going to start up the WhatsApp group and I'm going to post in times. And let me kick out all the old students from my WhatsApp group first. And so that I'll just post it in times, and that we can start discussions from there. And also you can email me anytime you need a consultations, or we can have Zoom sessions as long as I don't have class or meeting. Email me first, make an appointment, then we can meet online. Any questions so far? Don't worry about attendance. I just realized that Zoom has auto attentions taking. As long as you sign in with your official account, then I know who is in the class. And today I have full classes. Do we have tutorial tomorrow? Oh, that's a very good question. No, because do you think there's any tutorials can come out from this chapter? I don't think so. So there's no tutorial tomorrow. Thank you for that questions. For week 1 in safety class, there's no tutorial. Tutorial will start week 2 because chapter 2, we're going to talk about toxicology. There's a lot of calculations in chapter 2 and chapter 3. So that's where we will start to have tutorials, okay? So tutorial will only start week 2 onwards, means next week onwards. And if we have face-to-face class, or not the face-to-face class, if we have online Zoom class like this, I will post it in times, but tutorial is definitely, we will have a synchronized classes. But no worries, I have recording also. Any international students here, later you can drop me a message in the chat box and tell me your time zone, because if now is midnight for you, then for those who can't have these synchronized sessions because of time zone difference, then I will allow you to view the recording. If not, then I will expect you to be in the class, yeah? Any questions so far? If no, thank you for being here today. So I will end the class here. Any questions, you can just turn on your mics and ask, or you can just type in the chat box. If not, I'll see you next week. Okay, bye-bye.
Hi, Miss. Can I ask something?
Sure.
What does synchronized class mean?
Synchronized means like classes like this. Asynchronized means you can view it anytime. Means it's pre-recorded. Those videos that you put in times that some lecturers, they some lecturers, they prefer their lecture classes to be pre-recorded. Means that's what we call the asynchronized classes, where you can view it anytime. You don't have to view it only during this class time. Synchronized classes is where I'll be here. You can ask questions that I'll see you also called face-to-face online, virtually.
I see. So how are we gonna handle our classes? Both,
Okay.
is it?
We are going to do both. And some weeks that if I notice that the materials you can view it at your own timing, then I will just post it on Monday. Then I will just in times, just every Monday I will update it. You just have to see there's no classes. That means there will be no Zoom class. If you see the Zoom class is on, I'll give you the link there, then you come to the class. But tutorial will definitely be synchronized, means there will be a tutorial class that we discuss, so that I know at least you are still here with me. I try to do pre-recorded tutorial. Trust me, no one read it, no one viewed it. So that's where I don't want to do it anymore. I want you to.
Lectures will be mixed, right?
Yes, it will be mixed.
Okay. All right. Thank you, Miss.
Are you in Malaysia?
Yes. I'm in
Okay,
Malaysia.
good. Because I do know some of our friends are still in their home country. They still can't get in for whatever reasons, even though the borders is open at this moment for the students to come back. And some prefer not to come back because of the cases here are unstable, but it's okay.